Okay, this is 5.5 to 5.8 mechanics applied math. Okay, very easy, but هلا we're working with perfectly inelastic collisions and elastic collisions. Before we start, just so you can kind of remember, in an elastic collision, kinetic energy is conserved. Okay, so that means K initial is equal to K final. Okay, you need to know this. For elastic, kinetic energy is conserved. For inelastic collisions, kinetic energy is not conserved. Okay, what else is conserved in an elastic collision? Momentum is also conserved, so P initial is equal to P final. What else is conserved in an elastic collision? Mechanical energy. Okay, so I remember it came one time in the exam. What is conserved in an elastic collision? The three answers were momentum, kinetic energy, and mechanical energy. Okay, very easy. Many people, they didn't put mechanical energy, they just put these two, which I would understand why. But mechanical energy, don't forget, is kinetic energy plus potential energy. Since you're colliding, you're not going up and down, so there will be no change in potential energy. So therefore the kinetic energy, since it's the same, mechanical energy will also be the same. Anyways, let's start. A mass m1. Okay, before I continue, also relative speeds, just so you can know, relative speeds in elastic collisions, the relative speed of separation is not equal to the relative speed of approach. It is. In elastic collisions, the relative speed of separation is equal to the relative speed of approach. In inelastic collisions, the relative speed of separation is equal to 0. Okay, what is relative speed? It basically means if you have VA, an object A, it's moving at velocity VA, right? An object B moving at VB. The relative speed between them would just be VB minus VA, the absolute value. Okay, like a question came one time. It was, can I not open a new note? Hello. Yeah, over here, look. This was a question that came one time. Two identical billiard balls. They told us it's elastic, and they told us that the relative speed is 18.4. They said they rebound. Okay, rebound شو معناتها? One goes here, one goes here. Type one of them at 7.7. What is the speed of the other ball? If you see a question like this, if it comes same numbers and you put 10.7, it's multiple choice. But remember, for elastic collisions, the relative speed of approach is equal to the relative speed of separation. So 18.4 is equal to, let's say, V2 minus this 7.7. But here you're going to get V2 is equal to 20 something. But that's wrong. Why is it wrong? Since one rebounds in this direction and the other rebounds in this direction, you have to take a positive direction. So you want to take what's it called? I think they gave you something, they gave you a diagram on something in the question. But this 7.7 was in the negative direction. So when you do V2 minus V1, it would be minus minus and become plus. And then you'd get V2 is equal to 10.7 meter per second. That's how you get the 10.7. The minus minus becomes plus. So you have to get it from the question. This 7.7 was in the negative direction. And I didn't write down how the question came fully, but this was the general stuff. So if you see it in the exam, put 10.7. My whole point here is you need to know that the relative speed of approach is equal to the relative speed of separation in an elastic collision. Okay, anyway, here you have a mass m1 moving at 2 meters per second collides head-on with mass m2, which is 4 kilogram, moving at 6 meters per second in the opposite direction. Yeah, I think they said it moves in the opposite direction, something like this. Okay, anyway, so if you want to see how this looks, by the way, it's moving at 2 meters per second, so it's going like this, 2 meters per second, and it collides with one moving in the opposite direction at 6 meters per second, and it's 1 kilogram This is 4 kilogram. Type, if it's perfectly inelastic, what is the velocity of mass to m2 relative to mass m1? So what do they want? We want the relative speed. If it's perfectly inelastic, what do we know relative speed is equal to after collision? Always 0. Okay, always, it's a rule. If the collision between the masses is perfectly elastic, so it's elastic collision, then what is the mechanical energy of the system after collision? What do we know about the mechanical energy in a perfectly elastic collision? ME1 is equal to ME2, it's conserved, right? So basically, to find the mechanical energy after, what do? You just find the mechanical energy at the start. If they said command instead of mechanical, they said kinetic. Same thing, you just find the kinetic energy at the start because it's conserved. Okay? Anyways, what's the mechanical energy at the start of the system? We're gonna say ME1 of object 1 plus ME of, let's say, this is mechanical energy initial is equal to mechanical energy final. Okay, so this is ME1 plus ME2. That's what composes mechanical energy initial. Equals what? Let's see. Kinetic energy of the first object plus the potential energy of the first object plus kinetic energy of the second object plus potential energy of the second object. They didn't say anything. It's a collision. You always ignore the potential energies unless they say something was dropped from a height or anything. We don't care. Okay, so K1 plus K2, which is half times the mass times its velocity squared plus half times its mass 4 times its velocity squared. So you're gonna get calculator. You get 0.5 times 1 times 4 plus 0.5 times 4 times 36. Get 74 joules. Very easy. Type. Moving on, question 2. A mass M1 moving at 4 meters. A mass M1 moving at 4 meters per second collides head-on with a mass M2 moving at 8 meters per second in the opposite direction. Very simple. They're saying it's what? Perfectly inelastic. So what will mass M1 move at the speed of? Okay, very easy. This is just collisions. You just need to deduce that since they say perfectly inelastic, VA, or let's say in this case V1, is equal to V2, right? Because it's perfectly inelastic and they collide and move together, right? Anyway, so what formula do we use for any collision? We use this. Equals M1 VA. No, let me use 1 and 2 instead of A and B. 1, 2 plus M2 V2. Type. Mass 1 is 3. Mass as its initial velocity was 4. Plus mass 2 is 2. If you put the velocity as 8, you're gonna get it wrong. Why is it wrong? Because it's moving in the opposite direction. So you need to take a positive direction. We're gonna call this mass M1. This is M2. This is the positive direction. Okay, so this will be what? So if this is U equals 4 meters per second, this U2 will be negative 8 meters per second. Okay, since it's moving in the opposite direction. So mass 2, 2 kilogram, times U2, which is negative 8, equals mass 1, 3 V plus mass 2, 2 V. Why did I replace them with V? Like I told you, since it's perfectly inelastic, they collide and stick together to form one mass, so their velocities will be the same if it's perfectly inelastic. Anyway, so you're gonna get 12 minus 16 is equal to 5V. You're gonna get minus 4 is equal to 5V. So you're gonna get V is equal to negative 0.8 meter per second. So they said speed, so you keep it positive. Question 3. Okay, a shell is traveling horizontally at 400 meters per second. So you can say this is U, 400 meters per second, right? When it explodes into two pieces whose masses have a ratio 2 to 3. Okay, this is, okay, I'm going to continue. The larger piece has a velocity of 800 meters per second in the initial direction of motion. The smaller piece also moves horizontally after the explosion. Right. So the larger piece has a velocity of 800 meters per second. So you could say, let's call V large, V small. Okay, V large is 800 meters per second. V small, okay, they're going to want us to find it, yeah. We don't know. Right. Obviously, it's an explosion. There's bigger piece explodes into smaller piece, initial velocity, final velocity, and you kind of have masses, right? So we can use MA UA plus MB UB is equal to MA VA plus MB VB. So obviously we only have one object at the start. It's the big piece exploding into two pieces. So obviously we're just gonna cancel this out and we're gonna call this our big object, our like shell. Okay, the mass of the shell we don't know, we're just gonna say mass of the shell times its initial velocity, which is 400, is equal to, we're gonna talk about the larger piece and the smaller piece. The mass of the larger piece times the final velocity of the larger piece, which is 800, plus the mass of the smaller piece, which we don't know, times the velocity of the smaller piece, which we're trying to find. Okay, what do we need to do? We have this, but we have many unknowns, especially the masses. Okay, we need to model the masses. What do we have given about the masses? They said that the masses have a ratio of 2 to 3. So you need to be a bit good with math to kind of get what's going on here. You have the ratio of the masses are 2 to 3. So obviously the smaller mass to the bigger mass is 2 to 3. طب I want to rewrite these in terms of m, right? So what is m? Isn't it the big ratio? Isn't like the total ratio? Remember these exercises that we used to do in math in grade 5, grade 6. The ratio of boys to girls in a class is 7 to 6. What is the ratio of boys to total number of students? Okay, total number of students. How would you do this? It would be the number of boys 7 to the number of total students, which would be add this plus this, which is 13, right? So this is the exact same thing. You're going to do the same thing. Hey, this is the smaller mass to the bigger mass. What if I want to find the ratio of it to the total mass, the big mass? What is the original shell? Isn't it the original shell, the smaller mass plus the bigger mass, right? So now I want to write it in terms of m, which is the original shell. So let's say I want to write it in terms of the smaller mass to the original shell, which I'll just call m. How would I do that? It would be 2 to the total, which is 5, right? And if you don't know what this means, it basically means mass small over m is equal to 2 over 5. So can I find an expression for mass, the smaller mass, in terms of this m here? Of course I can. Just multiply m to the other side, you're going to get 2 over 5 m. Wow! So over here, can't I just substitute 2 over 5 m? Yes. Can I do the same thing for the large mass? Of course I can. Let's write the large mass in terms of the bigger mass. The mass large in terms of m would be what? 3, which is the number of mass large, to the total 2 plus 3, which is 5, like we did over here. So what does this mean? That means ml over m is equal to what? 3 over 5. Can I find an expression? Just multiply m. So you're going to get 3 over 5 m. You see how easy that is? So I showed you the full proof of how to get this. But if you see this in an exam, ms to ml is like 2 to 3. بسرعة, without even thinking, that means ms is equal to the bigger mass 2 over the total 5m. ml would be 3 over the total, which is 5m. Or you can go through what I did here. عادي. Okay, no worries. So anyways, now we have expressions for ms and ml. So I can substitute that back in, and then I can solve for vs, right? So yalla, m times 400 is equal to the larger mass, which is 3 over 5m, plus the smaller mass, 2 over 5m. Oh, I forgot to include the velocity, 1 second. Times 800, plus the smaller mass, 2 over 5m, times vs. Okay, can I cancel m with m with m with m? Yes, I can. So I'm going to be left with, I'm going to continue up here. 400 is equal to 3 over 5 times 800 plus 2 over 5 vs. Okay, can I solve this now? Of course I can. Yeah, let's get the calculator. Yeah, 400 minus 0.6 times 800 divided by 0.4. You're gonna get negative 200. Okay, So Vs is negative 200 meters per second. Not too hard. The only hard part was working with the masses. Okay. The ratio of the kinetic energy of the system after the explosion to the kinetic energy before the explosion is what? To find the ratio, I think it's very, very easy. Very, very easy to find the ratio. So they want us to find the ratio after, so kinetic final to the initial. So basically we just need to find the final energy and initial energy and divide them and find the ratio. How do we find Kf? We have a small shell and a big shell, so it will be kinetic energy of the small shell plus kinetic energy of the large shell. So it's gonna be half times, we don't know the masses, so we're just gonna replace it in terms of m. Remember we said the mass of the small shell was 2 over 5m, the mass of the large shell is 3 over 5m. Okay, so for the small shell it's half times the mass 2 over 5m v squared, so negative 200 squared, let me put this to the side, plus for the large cell half times the mass, which is 3 over 5m, times the velocity of it squared, which we said is 800 squared. The initial for the big shell, the original shell, half times the mass of it, m, times its velocity squared, 400 squared, right? So we want to find the ratio. All you have to do now is just calculate this. You can ignore m in this calculation, that's completely fine. But I'm just gonna keep it so that someone doesn't tell me, oh, you skipped this, Anyway, 0.5 times 0.4 times 200 squared plus 0.5 times 0.6 times 800 squared. So you're gonna get 200,000. Okay, here, hello, 0.5 times 400 squared, 80,000. Can we find the ratio now? Final over initial. Let's do it, yalla. 200,000 divided by 80,000. You get 2.5. Very easy. Okay. Ooh, here there was supposed to be m, here there's supposed to be m. But when you divide them, by the way, they obviously cancel. Huh? Question 4. A car of mass 1300 kilogram is being towed by a truck of mass 3900 kilogram at a speed of 61 kilometers per hour. An unexpected obstacle on the road causes the tow rope to let go of the car, and the truck now has a speed of 72 kilometers per hour. Since there are no external forces acting on the system, what will the speed of the car now be? So this is actually, think of it as an explosion. Okay, you have this big truck, right? This truck, it's carrying over here a car, right? Excuse my drawing. So it's moving, and then it suddenly splits into two pieces: the car and the truck. Oh, that's a bad drawing. Right? So it now splits into two pieces. So isn't this like what we solved in the previous question with the shell, the big shell exploding into two smaller pieces? Yes. So you can use the same logic. Okay? For most of these questions, without even thinking, this formula will apply to almost all questions. So if you have this formula memorized and you know how to apply it, I'm pretty sure, I'm confident you can get most of the questions right in this chapter. Okay, so obviously we're working with the car and the truck being one big mass, right? So this one, we're going to cancel it. We're going to treat it all as one big mass since they're moving together. right? So the original mass was 1300 kilograms plus 3900 kilograms, which is 5200 kilograms. Okay, just add these up. Okay, if you don't know how, so I'll write 1300 plus 3900 times. What is their initial velocity? They're originally moving at 61 kilometers per hour, equals mass A. We now split into the car and the truck, right? So we're going to treat them as two separate objects now, since we split off, they broke off each other, right? So the mass, we're going to talk about the car first. 1300 times velocity of the car plus the mass of the truck, 3900, who is now moving at a speed of 72 kilometers per hour. So this is very simple. You can solve this with your eyes closed. Velocity of the car, let's solve. You're gonna get عندك 5200 times 61 minus 3900 times 72 divided by 1300. There you go, you got 28 meter per second. Very easy, not too hard. Question 5. How many questions is this quiz? 12? Oh, not bad. Type, a girl of mass 55 kilograms runs towards her friend and pushes her with a force of 72 newtons. Okay, the push takes about 1.5 seconds, after which the first girl stops. The pushed girl initially has at rest has a mass of 61 kilograms. The speed of the pushed girl after impact to one decimal place is 1.8 meter per second. Let's see. Okay, over here we have you could say it's a collision, right? You have this girl, she's pushing the other girl, she starts moving, whatever, right? So we can use this formula, right? Let's call girl A, girl B, right? So our famous formula, MAUA plus MBUB equals MAVA plus MBVB. Type, we know that the girl was initially at rest, the second girl, so we're gonna throw that out. Type, we know that the first girl that pushed, she eventually stops. Final velocity is 0. So we're left with this, right? Equals MBVB. Type, the initial velocity of the first girl. This is a big problem because we don't have the velocity. So what did they give us here? They gave us the force and the duration of the force. They gave us the force and delta t. So can't we substitute her momentum with the impulse j, which is equal to force times delta t? We can, right? Many times we went over this. When they give you a force and the time, it's j, right? Which is also the momentum. So this MAUA, since we don't have a velocity, but we have the force and the time she applied the force for, you can substitute with F delta t. Okay, now the second girl, 61 kg, and we don't know the velocity she's moving at, right? So we're going to say VB. Now can you solve? Yes, you can. So you're going to say 72 times 1.5 equal to 61 VB. Then to one decimal place, you're going to get 1.77. Round it, you get 1.8. Very easy. Okay, so the key takeaway here is that if she doesn't give you, the velocity is not given for you, you need to see if they gave you a force and the time. Okay, they're always going to give you velocity, but maybe he gets you force and time. This is just to test your knowledge on whether you know that J, the impulse, is the same as the momentum. Okay, so this momentum can be substituted as J, which is F delta T. Question 6. A toy car of mass 2.6 kilos moves from rest down a smooth, long, inclined plane at an angle of 24 degrees with the horizontal. Okay. It collides with another mass 1.9 after 3 seconds. The second car was already moving down the inclined plane at half the speed of the first car at the moment of impact. Take G as 9.8, and given that the two cars combine after the collision and continue moving down the plane, so they combine, okay, and VA is equal to VB, their common velocity after 1.4 seconds is what? Okay. This is a type of question that you will definitely see if you're doing AS mechanics. Definitely. When you have an inclined plane, I always say it's better for you to draw. Okay, so you draw the 24 degrees, you have the first car over here, and you have a second car over here. Okay, so what do we have given? Let's call MA 2.6 kilograms, and let's call MB as 1.9 kilograms. What are they telling us? They give us the angle is 24, and they're saying that they collided after 3 seconds. So you could say the time, okay, before I say this, I'm gonna say that the time accelerating is 3 seconds. Why? Because this car, it accelerated down, right? It moved down. Obviously, it's speeding up because it's moving down a hill. Ya Allah. It's, don't tell me I lost it. Okay, it's moving down a hill. فأكيد it's speeding. Oh, يا أخي, stop. Yeah, it's speeding down because it's moving down a hill, right? It's going to be accelerating. How long did it accelerate for until it collided with car 2? 3 seconds. That's going to be called the time accelerating. طيب, what do we know? The second car was moving down the inclined plane at half the speed of the first car. When we do our collision, MA UA plus MB UB equals MA VA plus MB VB. From the given, they're telling us that U of the second car, B, is equal to half of the first car. Okay, so in other words, you could say that UA is equal to 2UB. And I hate working with fractions, so that's why I took it to the other side. So over here in your working, you can substitute this as UA, you can substitute it as what? 2UB, right? Plus MBUB is equal to MAVA plus MBVB. What else can I substitute? They combined after the collision. For this VA and VB, I'm just going to replace it with 2V. Okay? طيب, so we're going to say VA is equal to VB, which is just V. Okay, so now we have a nice equation, and we can substitute what we can. Let's substitute what we can and see what we still need to find. Okay, so mass A, 2.6, times 2 times UB, plus MB, mass of B, which is 1.9, times UB, is equal to, can I move this to the side? I don't think so. Okay, let me take this over here. Hey, because I want space. Type mass of A 2.6 times 2, right? Times UB plus mass of B 1.9 times U of B equals mass of A 2.6 times V plus mass of B 1.9 times V. Remember, we put V instead of VA and VB because they combine, so they have the same velocity. Anyway, so now we want to find this V, but we can't find it. Why can't we find it? Because we don't have the initial velocities. This is the problem. How do we find the initial velocities? We have some stuff given. Okay, we have stuff given that this car over here, it accelerated for 3 seconds. Okay, that's nice. If I know that it accelerated for 3 seconds, then I can maybe find a velocity. Type, what do we know? It started from rest, right? So I can maybe find the acceleration of it, right? I can find the acceleration and multiply it by 3 seconds to get the velocity, because you guys know velocity is equal to the acceleration times time, right? Type, okay, let's see. For the first car, it's on an inclined plane. What are the forces acting on the first car? And I want to find the acceleration. Let's draw its free body diagram. You have it going like this, right? Right? So let's draw the FBD. It's going to be like this. The weight will be going vertically downwards, and the angle between the weight and the vertical will be, let me make this bigger because this is very ugly, over here, okay, you have the first force acting on it is going to be the weight, right? And it's going to have 24 degrees over here. طيب, what else is acting on it? They didn't see any friction. Obviously, we're going to have the normal push, right? طيب, so in this case, we're going to have the y component of the weight and the x component, so wx and wy. Okay, now we start to see some forces. Obviously, the car isn't jumping up and down, so sigma fy is equal to 0. So we're going to get that n is equal to wy. This, we don't care about this. We don't care about sigma fy. So you can simply skip this step. نحن we are moving it horizontally. أصلا they're saying it's moving horizontally. Okay, so sigma fy shouldn't mean anything to you unless they tell you something about friction. But there's no friction. You won't get a question that's hard and they tell you friction. Anyway, so it's moving horizontally and it's going to be accelerating horizontally. So what inta you should only care about is sigma fx. And since it's accelerating, it's going to be equal to what? ma. Perfect. What do I have along the x-axis? What are my horizontal forces? I only have wx, right? So wx is equal to its mass, 2.6, times a. Okay, what is wx? Isn't wx mg sine alpha? Why is it sine? Because angles with the vertical, right? So to find the horizontal component, you do sine. Okay, I'm going to continue this. I'm going to go here. wx is equal to 2.68. wx is mg sine alpha, right? The weight is w. Since it's the x component, you want to find the horizontal component, you do sine, since the angle is with the vertical, right? So mg sine alpha. Let's see. Is equal to 2.68. mg, the mass is 2.6. G is 9.8. Alpha is 24 degrees. Equals 2.6a. Can I find this? Of course I can. You can cancel us on 2.6 with 2.6. You're gonna get that 9.8 sine 24 is your acceleration. 9.8 sine 24. 3.986. So therefore, a is 3.986. Okay, I now know it accelerated for 3 seconds at 3.986 meter per second square. Can I find the velocity? Yes, I can. V is equal to at. So therefore, V is equal to this 3.986 times 3. Let's see, 3.986 times 3. You get 11.958 meter per second. This is what the initial velocity of what? Object A. Type. And I have it here in terms of UB. And we know that UB is just half of UA, so let's divide this by 2 and get 5.979. So now I can continue my working by substituting UB as 5.979. Let's see, 2.6 times 2 times UB, which is 5.979, plus 1.9 times 5.979 equals 2.6V plus 1.9V. Yeah, let's do it on a calculator. 2.6 times 2 times 5.979 plus 1.9 times 5.979. Type divided by 2.6 plus 1.9, and you get 9.43. Someone's gonna come and tell me, Waleed, why is the answer 15? This is the velocity after collision. What do they want? They want the common velocity 1.4 seconds after the collision. So the same step that I did here to calculate the acceleration doing v equals at, I have to now do that. So I need to calculate now the acceleration. Same thing, but what happened is now they're stuck together, right? So they're moving together. So it's going to be the same FPD as this. So literally the same FPD as this. You have consider it all as one mass. You have the weight, you have the norm pushing up, you have the weight going down. This is Wx, and this is Wy, and you have again 24 degrees. So I'm going to be reusing this FPD. Okay, same thing. We're accelerating horizontally, so sigma fx is equal to ma. So what does that mean? Wx is equal to, what's the mass now? What's the mass? It's all one object, so 2.6 plus 1.9 a. Right, let me add this up and you're gonna get I'll continue here, huh? So Wx is equal to 2.6 plus 1.9 is 4.5 a. Okay, what is Wx? mg, the weight, times sine alpha, right? Type, okay, what is mg sine alpha? What's the mass of it? 2.6 plus 1.9, which is 4.5, times 9.8 times sine 24. Cancel 4.5 with 4.5, you're going to get a is equal to 9.8 sine 24, which is the same acceleration that we found previously. Okay, 9.8 sine 24, which was how much? 3.986. Okay, so now we know that it's accelerating at 3.986 meters per second square. Yeah, okay, sorry, and I had to cut off. I think I was saying that we found the acceleration and we know it was accelerating for 1.4 seconds. So, of course, now we can just apply v is equal to acceleration times time. But you're gonna get, you have to add the initial velocity that we found here, because they started accelerating from 9.43 meters per second. So you can't forget that 9.43. Also, the formula is v is equal to at plus u, if you guys remember from chapter 1. Anyways, v is equal to the acceleration that we now found, 3.986. So this is plus, plus, 3.986 times 1.4. You're gonna get 15 to one decimal place to the nearest integer, as they ask in the question, 15 meters per second. So we're gonna do v is equal to 9.436. 3.986 times the time 1.4 plus 9.43 is equal to 15 meter per second. Okay, so that was a long question. It was hard, not hard, but there's a key takeaway here that you need to find. There was a key point that you needed to find, and that was the acceleration. Okay, to find the acceleration without wasting time, the acceleration is horizontal. If I just figure out the forces acting horizontally and just do sigma fx is equal to ma, it's not that hard. Okay, but you don't really usually see questions like this in the exam. This is something you would see in a written part. But yeah, that's it. Don't know what else to say. Okay, question 7. A particle of mass 2.5 kilograms, if I give them mass, very nice, has a momentum of 4 kilogram per meter per second. Okay, so they gave you the p value. They said it's moving with an unknown velocity. What is the kinetic energy? So now to find kinetic energy, it's half mv squared. Type, I need this velocity. Can I find it? I know that I have p, which is equal to mv, right? And we have the mass, we have the p, so we can easily find the v. So 4 is equal to 2.5 v, so v is equal to 4 divided by 2.5, which I have no idea what it is. 1 second. 4 divided by 2.5, 1.6 meter per second. طيب هلا we're going to go back to the kinetic energy, so it's going to be half times 2.5 times the velocity squared, so it's going to be 0.5 times 2.5 times 1.6 squared. You get 3.2 joules. I don't know why they put newtons, that doesn't make sense. Anyways, question 8. Two pucks, they're identical. Okay, so two identical pucks, A and B, they both have mass m, and they're moving along the same straight line on an air hockey table. Type, puck A is moving with 2.1 meter per second, which strikes puck B moving at 1.5 in the same direction. Type, يعني اثنينتهم they're going like this. Okay, هيدي A, هيدي B. Anyways, after the collision, both pucks move in the same direction, but the speed of B is 0.6 greater than A. So we can say VB is equal to 0.6 plus VA, right? طيب, what do we know? They gave us UA, which is 2.1, or they gave us UB, which is 1.5 meter per second. Hello. So we have nice given. What is the speed of puck B after a collision? So we have a collision. So what will we do? MAUA plus MB UB equals MAVA plus MB VB. Since they are both identical and they both have the same mass m, we can just cancel the masses. So we're gonna get UA, which is 2.1, plus UB 1.5 is equal to VA plus VB. We don't know. We can't solve with two variables, right? But they gave us that VB is 0.6 greater than VA, so we can substitute VB. So we're gonna continue. 2.1 plus 1.5 is 3.6 equals VA plus 0.6 plus VA. خدها لهيني لهوني. Take the 0.6, you're gonna get 2VA is equal to 3. If you continue, you're gonna get VA is equal to 3 divided by 2, which is 1.5 meters per second. But are they asking for VA? No, they're asking for the speed of puck B. So we need to substitute this back into VB, and we're gonna get VB is 0.6 plus 1.5, which is 2.1 meter per second. Nice. Okay, due to the collision, puck A loses something Newton second in momentum. Let's see. So here they're telling us, find how much did it lose momentum. So to do that, I need to find how much was the initial momentum and how much was the final momentum for puck A, right? So initially, let's erase this. I can work here actually. Initially, puck A was moving at 2.1 meters per second. So we know P is equal to mv. So to find the initial momentum of P of A, it's the mass m times the velocity it was moving at, which is 2.1 m. Okay, so this is the initial momentum. The final momentum we found to be the velocity of A is 1.5. So the mass m, again, times 1.5. So it's 1.5 m. So how much did it lose? How much did it lose here? Just do 2.1 minus 1.5. You're going to get 0.6. And obviously m, and then the unit. Right, so this is your answer. They already put m for you. Okay? Very easy, not hard. Okay, the loss of kinetic energy due to the collision. How do we find kinetic energy? We need to find the initial kinetic energy. We need to find the final kinetic energy. Right? طيب يلا, let's do it. The initial kinetic energy, initially of the system, we need to find the initial of A and the initial of B. Right? طيب, okay, perfect. The initial of A is going to be half times m times VA squared. The initial speed of A squared. So not VA, I should have said UA. Right, so half, if you don't know, kinetic energy is half mv squared, in case you don't know. The initial speed of A was how much? 2.1 squared. Type plus, same thing with B, the mass, remember, they both have mass m, type times its initial speed, 1.5 squared. Okay, perfect. You're gonna get, let's cancel m with m, because the other one will also have m So we're gonna get 0.5. You don't actually keep it in terms of m, don't cancel. Because if it's written and you cancel just like this, it's not nice. Okay, 0.5 times 2.1 square plus 0.5 times 1.5 square. You get 3.33. Obviously, you can't forget the m. Type joules. This is the initial. Final will be k final of A plus k final of B, right? So let's do it. Half times m times, what's the final velocity of A? 1.5 squared plus half times m times, what's the final velocity of B? Where did we say? We said it's 2.1 over here. So 2.1 squared. And isn't this just the same thing as the one up? Yes, so you're going to get 3.33 m joules. So what's the loss in energy? What's final minus initial? In this case, they're the same thing. For the initial, the loss is 0. Very easy. Question 9. A small sphere of mass 5 lies at rest on a smooth horizontal table. A second smooth sphere B of mass 2 kilograms is moving with speed 4 meters per second and collides directly with A, and the two spheres combine. Okay, so VA equals VB equals, we're just going to replace it with v. Okay, what is their common speed and what is the loss of kinetic energy? So this is a simple collision. You got used to these questions. خلاص. MAUA plus MBUB equals MAVA plus MBVB. In case you don't know, U means initial speed, huh? Because some people they might be like, they're just solving or they don't know what U stands for. U is the initial speed. Other people call it V0 or V initial. Adi, doesn't matter. Okay, but I'm using U because for external exams they always use U. Okay, and I got used to, since I'm doing the externals, I got used to it being called U. Anyways, initially sphere A was at rest, so that means we're gonna cancel it out, right? Its initial momentum, since its initial velocity was 0. MBUB, mass 2 kilograms times its initial speed 4 equals MA, which is 5, times V plus mass B, which is 2, times its final speed V. Why did I replace them with V? Because we said that they combine after impact, so they move as one, so they have the same velocity. Anyway, so you're going to get 7V is equal to 8, so V is equal to 8 over 7, which is 1.14 meter per second. What is the loss of kinetic energy? As usual, we find the initial and we find the final and subtract. Initially, we only had one sphere moving, and this was 0, right? The other sphere was moving, so it's kinetic energy of A is 0. That's why I'm skipping directly to the second sphere. Huh? Why is it 0? Because it was at rest. Anyway, so the velocity was 0. Anyway, kinetic energy of B, half times the mass of B, 2 times its velocity, 4 squared, right? Again, this is the formula I'm using for kinetic energy, in case someone is still confused. Okay, which is 16 joules. Type on final, they're both moving now, right? So half for A, half times the mass of A, which is 5, times its velocity, which we found to be 1.14 square, plus for sphere B, its mass is 2, times its velocity squared that we found 1.14 square. In case someone's a bit confused, let me just write on the side, K initial is equal to K initial of A plus K initial of B, but this is 0. And then for K final, it's K final of A plus K final of B, which is half mass of A times velocity of A squared plus half mass of B velocity of B squared. I'm just writing this down for clarification because I'm solving without writing formulas. Okay, there you go. Type, let's do this on a calculator. 0.5 times 5 times 1.14 square plus 0.5 times 2 times 1.14 square. You get let's just say 4.55. Say 4.55 joules. Subtract them now. How much did we lose? 16 minus 4.55. You get 11.45. To one decimal place, it's gonna be 11.5. Very easy. So K initial minus K final is equal to 11.5. When you're calculating the loss, okay, you do initial minus final, because if you want to see how much you lost, you compare how much you had initially to how much you had at the end, right? Question 10. A 50-gram bullet is traveling at 450 meters per second, collides with a 4-kilogram wooden block, and it becomes embedded in it. Would you consider the collision elastic or inelastic? It's becoming embedded. شو يعني embedded? Embedded is a keyword, by the way, you see in most questions when you have an inelastic collision. You see embedded or they stick together. These two are keywords to show you that it's what type of collision? Inelastic. Okay, so for this reason, obviously it's inelastic. Anytime it sticks together and moves as one object or embeds itself, yani it sticks to it and becomes one object, that's inelastic. What is the velocity of the bullet block system immediately after collision to one decimal place? So obviously, since they're embedded, they're referring to it as one whole system, which is completely fine. Okay, so V bullet equals V wood, which is equal to just V. So let's do our famous collision formula, MAUA plus MBUB equal to MAVA plus MBVB. ماشي. In this case, let's treat B as the bullet and W as the wood. Okay, so mass of the wood, V of the wood. طيب, since the wood was obviously at rest, this was the wood over here, you have the bullet coming like this, right? It comes inside of the wood, like hits the wood, and pokes a hole through the wood, or whatever, and becomes embedded in it. The wood was initially, obviously, what was it moving? Was it jumping around? No. So the U of the wood was 0. So therefore this is what? 0. Okay, ماشي. For you only have mass of bullet, U of bullet. The mass of bullet is 50 grams, so it's going to be 0.05 kg, right? Times the U of the bullet was initially traveling at 450 meters per second. Okay, equals mass of wood, which is 4 kilograms, times the velocity of wood, we don't know. We're going to refer to it as V, as we said over here. Since they both have the same velocities, we can refer to both of them as V, plus mass of bullet 0.05 B. ماشي. Solve this, it's very easy. 0.05 times 450 divided by 4 plus 0.05, which is 4.05, and you get 5.5, yeah, to one decimal place, 5.6, right? Therefore V is approximately 5.6 meter per second. What is the percentage of the kinetic energy dissipated as heat? Basically, when we say dissipated as heat, we want to find how much was lost. Okay, so let's take a look. How much kinetic energy did we lose? To do that, we need to obviously find kinetic energy initial. Okay, initially in the system, it would be the kinetic energy of the wood plus the kinetic energy of the bullet, and this was at rest, so it's 0. So therefore, it's going to be equal to half times the mass of the wood, which is 0.05. Because remember, kinetic energy is half mv squared, huh? Times its velocity squared, so 450 squared, and this is going to be 0.5 times 0.05 times 450 squared, 5062.5 joule. Right, perfect. K final would be kinetic energy of K final of the wood plus K final of the what? Bullet, صح? طيب, yeah, so it's going to be half times the mass of the wood, which is 4, times its velocity squared, so 5.6 squared. Don't forget on they're embedded, so the wood and the bullet have the same velocity, plus half times mass of the bullet times its final velocity squared. Okay, it's a bit messy, but pardon me please. 0.5 times 4 times 5.6 square plus 0.5 times 0.05 times 5.6 square, 63.5 joules. Okay, so we need to see how much of the percentage was lost as heat. طيب, أول شيء, how much was lost أصلا? Ignore percentage, how much was lost? 5062 minus 63.5, let's do it. 5062 minus 63.5, you get 4998.5. So the K lost is 4998.5 joules. This, I want to see how much is it as a percentage. Okay, how do we find percentage? How much percent of 5062.5 is 4998.5 joules? I think everybody knows how to calculate this, especially if you're doing the SAT. This is one of the simplest questions you can get. To find the percentage, just divide this by this and times 100, right? So 4998.5 over 5062.5 times 100. Yalla. 4998.5 divided by 5062.5 times 100, and you're gonna get, to the nearest integer, it should be 99%. Let me see what they put here. Yeah, 99%. Okay, that's nice, very easy. Question 11. It wants to load. Okay. When a particle of mass 0.3 kilos is moving with a velocity, okay, see, we're working with vectors now, is moving with a velocity minus 9I plus 12J, so this is its velocity. ماشي, it collides with another particle of mass 0.4 initially at rest, U equals 0, right? Let's call it UB. طيب, after the collision, B has a velocity of 6I, so they gave us VB. Hello. What is the impulse received by particle A? يلا, let's see. Okay, so over here they want you to find the impulse received by particle A. Now, do we have anything about force or time? No. So what do we say when there's no force, no time for impulse? We say it's just a fancy way of saying delta P, which is what? Delta V, right? We're talking about A. But we need to find the final velocity of A, right? They didn't give it to us. They gave us UA. They gave us UB, which is 0. They gave us VB. And they told us في collision بالموضوع, but they didn't tell us VA. So obviously we're gonna have to find VA. So let's do our famous collision. Our famous collision formula: MA UA plus MB UB equals MA VA plus MB VB. يلا. B is initially at rest, so we're gonna cancel this out, right? For MA 0.3, it's initially moving at minus 9I plus 12J equals MAVA 0.3, we don't know VA, plus MBVB, so 0.4 times the final velocity of B is 6I plus 0J, we don't care. Simplify, you're gonna get negative 2.7I plus 3.6J, 3.6, 0.3 times 12, 36, 3.6J equals 0.3 VA plus 2.4I. Take this there, you're gonna get minus 2.7 minus 2.4 will be minus 5.1I plus 3.6J is equal to 0.3 VA. Divide by 0.3, you're gonna get VA is equal to minus 17I plus 12J. This is your VA. هلا, can we apply M delta V for A? Yes. Right? Let's do it. The mass of A is 0.3. Delta V will be V final minus V initial. This is V final, right? So minus 17I plus 12J. This is my final. Minus the initial velocity, minus 9I plus 12J. Yeah, obviously 12 will 12, they're gonna cancel. Minus 17 minus minus 9 will be what? 8. Minus 8I. You're gonna end up getting minus 2.4I. It's negative. I don't know why the answer here is positive. Okay, I really have no idea. If anybody knows, please tell me. حتى the AI gave me negative 2.4. بس I got negative. I don't know why in the quiz it's positive. If you know, please tell me. Question 12. A ball of mass 2m is moving at 10 meters per second, collides with a stationary heavy ball of mass 6m. The lighter ball bounces off at 90 degrees with its original direction at 1 meter per second. Do we have angles? Yes. When we have angles, I always tell you, you need to use vectors, resolve into x and y. Other people, they solve x separate and y separate, and I solve it all together by using vectors. And in my opinion, that's the easiest way for me. I don't know about you. Anyway, so let's use vectors. We have initially, this is the first diagram, and this is after collision. Initially, we have our friend here. He's moving at 10 meters per second, but he's going horizontally. So as a vector, this is going to be 10I plus 0J. You need to do this as a phi directions. Okay? So we're going to call UA as this. B is stationary, it's 0. طيب, بعد الكوليجن قالولنا lighter ball BA, it goes at 1 meter per second. As you can see here, it's making 90 degrees. He said it's making 90 degrees. So as a vector, how will that look? Is it moving horizontally at all? No, right? So it's going to be 0I plus is going up 1j. Perfect. Okay, VB we don't know. This is what we need to find over here, right? So it's a collision, فأكيد we're gonna do MAUA plus MBUB is equal to MAVA plus MBVB. طيب يلا MA is 2M times UA 10I plus this is 0, right? Because it was at rest. So let me erase this. Equals mass of A 2M VA, which is 1J, plus MB, which is 6M, VB we don't know it. Yalla, 2 times 20, 2 times 10 is 20, MI equals 2MJ plus 6MVB. This M is annoying, so we can cancel it. So you're gonna get 20I is equal to 2J. I need to put vectors now. Okay, plus 6VB. Take this to the other side. 20I minus 2J is equal to 6VB. Divide by 6, you're gonna get 10 over 3I minus 1 over 3J is equal to is equal to VB. طيب, we found VB, but they want it as a speed. So what do? We find the magnitude. How do you find the magnitude? VB, the magnitude, would be radical. Okay, you need to put this as a vector by the way if it's written, huh? Radical 10 over 3 square plus minus 1 over 3 squared. If you choose to include a negative sign, make sure it's in under the brackets and the square is outside, huh? Anyway, radical 10 over 3 square plus 1 over 3 square, close the bracket. You get 3.3 meters per second. What if they asked you what is the direction? In what direction? In what direction, when you have a vector and they ask you in what direction, what are they saying? They're basically saying, what's the angle, right? How do you find the angle? We know the angle it makes with the horizontal will be tan inverse y over x, right? In this case, y is negative. No, عادي, there's not. You just do shift tan. You only add 180 if x is negative, if you remember the vector rules for shift tan. Anyways, so you do shift tan. If they asked it, y over x, so 1 divided by 0.33333 divided by 3.33333. This is negative. You get, this is your angle, negative 5.7 degrees. As you can see, it's kind of making that angle if you were to draw it over here. See, it's a very small angle, 5.7 degrees. Okay, هيك نكون خلصنا. Thank you so much for watching and good luck.